Greetings and welcome to the ShiftLeft webinar. My name is Manish Gupta. I'm the founder and CEO of ShiftLeft. A little bit of background I want to give you about myself so that you know what context I'm speaking from. I've been in the security industry for more than 15 years. Most recently as the head of products and strategy at a company called FireEye, and before that, very briefly, I ran the security business at Cisco, and before that, the network security business at McAfee. That is to say that over the last 15 years, I've focused my energy on detecting threats. The early part of my career was focused on detecting viruses. Then I was focused on detecting worms. Anyone remember Conficker, Nimda, Blaster? And more recently, at FireEye, I was focused on detecting modern malware, nation-state attacks. And despite having done this for the last 15, 16 years, in early 2016, we were still seeing more than 100,000 pieces of new malware a day at FireEye. It was roughly at the same time frame when I was talking to my customers who were increasingly telling me that they're writing ever more software. Software is the engine of innovation across different functions, across different industries, and how customers are deploying more and more software into the cloud, public and private. And it was these two things that didn't sit well with me. How can software be the engine of innovation if we are going to play whack-a-mole with threats like we've done over the last 20 years? Because clearly, if we were to grade security over the last 20 years, we would give it no better than a C. And that is the genesis of ShiftLeft. We started the company with the goal of protecting software without reacting to threats. And as we talk about on this particular title slide, software is characterized with a high degree of change today. Gone are the days when we used to see one software release in 6 months. We are now working with customers who are doing 20 releases a day. That pace of change is not something that legacy security tools know how to deal with. At ShiftLeft, we embrace this pace of change to protect the software without reacting to threats. So let's double click on this and see what exactly do I mean. Historically, all of you in the audience, I'm sure you have data centers and or DMZ. Historically, you bought applications, let's say Microsoft Exchange and Oracle CRM. You would have deployed them in your data centers. And then you would have protected all of these applications using a variety of security technologies, starting with the firewall, perhaps adding intrusion detection and prevention, maybe deploying antivirus on the server. At the application level, at the application layer, you would have used a web application firewall, and so on and so forth. The key thing to notice that in this architecture, every single security technology is reacting to threats. Antivirus is writing signatures for viruses. IDS is writing signatures for worms. And if we see a new threat tomorrow that these technologies cannot detect, they have to write a new signature, a new algorithm. Fundamentally, security for the last 20 years has been reactive, and we've all experienced that ourselves. At ShiftLeft, we flipped the problem on its head, and we asked ourselves the question, what is it that we are trying to protect? Well, what we're trying to protect is this piece of software right in front of you here on this slide. And in this modern world today, it consists of custom software, software that your engineers are writing. Increasingly, it consists of a slew of open source libraries and a few third-party libraries. And all of this together constitutes a modern application, a modern microservice or a workload. And all of this needs to be protected from data leakage. Our perspective is that as software moves into the cloud and becomes SaaS, we are aggregating huge amounts of information. And first and foremost, we need to protect the software from data leakage. We then need to protect the software from attacks against known vulnerabilities. In the last year, we've seen an example of a significant organization losing large amounts of data because unknown vulnerability was exploited. And finally, we need to protect the software from unknown vulnerabilities, vulnerabilities that we don't know yet exist in the software. This is what ShiftLeft does. Every time the software changes, we protect it from data leakage, known vulnerabilities, and unknown vulnerabilities. I made some tall claims in the previous slide, so let's double click on seeing how exactly we do this at ShiftLeft. And before I go into the details, it's perhaps appropriate to take a step back and see that software to date has two separate life cycles which are largely disconnected. On the left side, software is in the development phase. This is where the engineers are writing new software, giving it to QA, who's testing it. They're both collaborating using some sort of a bug tracking system. They're adding new features. This is perhaps where we do static analysis and dynamic analysis to find vulnerabilities. And this cycle goes on. On the right side is where software is placed in production. And like we discussed earlier in a slide, this is where you're deploying a firewall, an intrusion detection system, a web application firewall to protect the software from threats. But notice that these two worlds of software, development and production, almost never talk to each other. That is the first thing we land up doing at ShiftLeft, is we create a continuous improvement cycle which brings these two disparate worlds together. Why? Because they are, after all, two facets of the same thing, which is code. So let's talk about how we do this. Let me call your attention to the bottom left, which says ShiftLeft Continuous Integration Plugin. In your organization, you might be using Jenkins, Circle, or Travis as your CI tool. Well, we will give you a plugin, which is a very small footprint and literally not take you more than 10 minutes to install it. Once installed in your continuous integration environment, the CI tool will leverage this plugin every time it sees a new version of a piece of software to conduct modern code analysis on that piece of software to extract its security DNA. This, of course, raises the question of what exactly is modern code analysis and what is security DNA. So modern code analysis is the invention of our chief scientist, gentleman by the name Fabian Yamaguchi, who's done his PhD in the area of code analysis from Germany. Fabian has come up with a novel approach of converting source code into a graphical representation, very much like Google PageRank, which allows us to suss out all the relationships in code extremely quickly and accurately. In 2015, Fabian published an IEEE paper in which he explains this approach and uses this approach to find 18 zero-day vulnerabilities in the mainline Linux kernel, all of which have since been acknowledged and fixed. And he also got a congratulatory email from Linus Torvalds himself. As we all know, that doesn't happen very often. So that is modern code analysis. What is security DNA? Well, think about security DNA as everything that is security relevant in this piece of software. While we will double click on this at a later slide, for the purpose of this discussion at this moment, suffice it to say that security DNA consists of all the inputs, all the outputs, all the open source libraries, what are the vulnerabilities, etc. So if you rewind back, every time a new piece of software is developed, your CI tool is going to use our ShiftLeft plugin to conduct modern code analysis on this new piece of software to extract its security DNA. And here's the kicker. We do this in less than 5 minutes. Meaning, every time you're developing a piece of software, we are able to extract its security DNA in less than 5 minutes. We then expose the security DNA to the development team, and they may choose to fix whatever we found. But knowing fully well that not everything gets fixed because of time to market urgencies, we then take the security DNA to create a policy for our runtime microagent to protect this application against its very specific attack surface. And it is this approach that allows us to protect this application, as you can see, without reacting to threats. The first programming language we are supporting is Java. And so in Java, the microagent is instrumented into the Java virtual machine. So let's take a few examples to drive home the elegance of this approach. Let's say this piece of software has 100 SQL queries. But as we've done the extraction of security DNA, we've concluded that on line 100 is a SQL query which is using a variable X, which it receives from the network interface and is not validating it before using it in the SQL query. And that is what causes SQL injection. The other 99 SQL queries are perfectly fine. All the other variables being used in SQL queries are perfectly fine. It's only this variable X at line 100 on the SQL query. Knowing this, our runtime microagent surgically instruments only line 100 and only look at the input to that variable X to see whether that is going to cause SQL injection or not. Let's pause for a moment to think how this compares to state-of-the-art implementations of web application firewall or even runtime application self-protection. All of them are largely threat-focused without any understanding of the underlying application. So they will usually create a large bunch of false positives, and depending upon the implementation, have significant impact on the performance of the application. Why? Because they have to instrument the application in multiple places. Deep understanding of the code helps us precisely instrument the application where it is vulnerable. Let's use another powerful example. Let's say on line 200 of this same application, the application is using an open source library, a Java library, which does not expect you to serialize data. That's part of the assumptions made by the Java library. But given that we are asking our developers to run ever faster, people are not usually able to read documentation. They don't have the time. And so this application is serializing data and submitting it to this open source library. An example of such an attack was San Francisco Muni in 2015, was taken down because of this exact vulnerability. And all you have to do is Google to see Java serialization, and it often comes up as one of the key challenges in security that we face today. So this is one of the key things that we do at ShiftLeft. When Jenkins calls the plugin, at that point, we get the understanding of all the open source libraries being used in this application. And we independently create the code property graph, the graphical representation of source code for each of these libraries. And then we create the code property graph of your application, and we stitch them all together depending upon how your application is using these open source libraries. As a result, two key things happen. If there is a vulnerability in the open source library, we will identify that. But if you're not using the vulnerable portion of that library, we will not tell you to upgrade it. We will tell you only to upgrade it, only to fix the issue when you're actually using the vulnerable portion of the library. So going back to our application example, Line 200, you are serializing data into an open source library that is expecting you not to. Again, while you're running the application, we know this. So at line 200, we're surgically instrumenting the variable that we are expecting you to serialize. And if and when that happens in production, we can detect it. I want to use one final example to drive home the point, and this is actually my favorite example. One of the other things that we do, excuse me, as we analyze the code, as we're analyzing the source code, we extract using natural language processing and a little bit of machine learning, we extract all the important variables that you're using in your source code. So as an example, in your source code, we find you have a variable called customer underscore CC. There are lots of other contextual information that helps us conclude that this is a variable that stands for customer's credit card number. And then what we are really good at is understanding how this variable flows through your source code. So as we've analyzed this particular application, we've concluded that at line 300, you are writing this variable to a logger without any transformation, without any encryption. With this knowledge, again, when the application is running in production, we will surgically instrument line 300 only to catch when that variable is being written so that we can tell you that you're leaking data. If we assume that this particular application has only these three weaknesses, you can see the power of this approach. We are only instrumenting the application in three places. And even in those three places, we specifically know what to look for. As a result, this approach gives us a solution that is very high efficacy, minimal false positives, but also very high performance. At this point, I often get asked the question, well, if you find all of these issues, why won't I just go fix them? Well, I think this is precisely we call the company ShiftLeft. Our belief is that eventually we have to fix the applications in order to do a better job with security. Yet it's time to market pressures that don't allow us to always fix all the issues we find. So at ShiftLeft, we've created an approach where you can have your cake and eat it too. We tell you of the vulnerabilities. If you fix them, the runtime agent doesn't have to look for much. If you do not fix them, we protect you. We detect items that we see that you've not fixed yet. So far, we've talked about how code analysis informs the runtime. But clearly, there is the bottom part too, where runtime data is leveraged to inform code analysis. I've often seen in my past experience that code analysis results usually tends to create a lot of false positives. And because developers are running very fast, the baby gets thrown out with the bathwater. And I've often also heard reasoning such as, well, this is in private microservice, or this is a piece of code that'll never get executed. Well, guess what? We don't have to take those guesses anymore. We take the production data, we take the runtime data and tell you that, look, the /login, where we did find a vulnerability that you thought was never going to get executed, I'm seeing 23 calls per minute being made. So it is something that, while we have not seen anyone exploit it yet, you should go fix it because clearly it does show up in production. And that sort of summarizes how ShiftLeft creates this continuous security improvement, leveraging code analysis to inform runtime and get very accurate, precise runtime protection, but also get the runtime data to feed it back into code analysis so that we have production data to help us prioritize what should be fixed with what degree of priority. As we talked about, We are focused at the application layer. And more precisely, we are instrumented within the application. As a result, what you run this application on, what infrastructure you run this application on, doesn't matter to ShiftLeft. So that means if you're using microservices, if you're using monolithic applications, if you're using containers or virtual machines, if you're using Linux or Windows as the operating system, or if you're using Amazon, AWS, or Azure, or your private cloud, none of that really matters to ShiftLeft. As a result, you have a solution in ShiftLeft where you get application level protection, in fact, surgical application level protection, regardless of where the app is deployed. So let's double click a little bit into the technology. The first thing, we talked about security DNA of the application. So let's double click on exactly what that means. Well, our perspective is that, look, if we create an application which has a bunch of vulnerabilities in it, but as long as that application doesn't talk to anything outside, you can't exploit this application. Meaning, it's the inputs, the entry points that become paramount in understanding what are the weaknesses in a particular application. And that's precisely what we look for. On the top left, what are the entry points? Are you validating them? Are you sanitizing them? Is there appropriate access control and authorization? For data leakage, the outputs become very important. And hence the bottom right, exit points. What variables are you writing where? Are you transforming a credit card number before you write it to a logger? We've seen a new version of a microservice and there's a new destination that has come up. Is that approved? Should you be writing sensitive data to it? And this is where recent regulations such as GDPR, this approach becomes very elegant because fundamentally all of these regulations like GDPR, PCI, etc., are asking the following four fundamental questions. What sensitive data are you using? How are you using it? Are you storing it appropriately? And who all have access to it? As we talk to customers, rarely do we come across people who actually know what sensitive data they're using and where in the massive infrastructure, which is evolving on a daily basis, is all of this sensitive data stored. That is a hard problem, and ShiftLeft can address that problem at the very source where you create that data, and that is the application. Every time it changes, even if it changes 20 times a day, we can tell you what sensitive data you're dealing with and where are you storing, and are you storing it post any transformations. And this is where the bottom left, the sensitive data elements comes in. As I mentioned earlier, we use natural language processing and some machine learning to identify all the important variables and classify them in different categories such as financial data, healthcare data, etc. And on the top right is the open source software. As I mentioned, we get a list of all the open source libraries that your application is using and create individual code property graphs, stitching them all together to create a code property graph for the entire application alongside its open source libraries, which is what allows us to very easily understand that you're using either a vulnerable portion of an open source library or you're accidentally submitting a sensitive data to a variable in that open source library, which let's say is being written to a third-party API. That shouldn't be happening. Let's also talk about what is underlying the modern code analysis, which is Fabian's conversion of source code into the code property graph. By the way, there is a white paper on our website that you can also read through. This is the IEEE paper from Fabian if you want to see more details. But bottom line, these are the three seminal formats of a piece of software. They've been around for a while. Most static code analysis approaches will use them. They are abstract syntax tree, the control flow graph, and the program dependence graph. And what's unique about ShiftLeft is that instead of creating these separately and looking through them separately, we combine all of these into one singular graph and allowing us to very rapidly search through them and apply some machine learning technology to very quickly identify the exact flows that we're looking for. And so how does this all come together? This sort of shows you an end-to-end pipeline. On the very left is where the ShiftLeft is embedded into your CI system, the continuous integration system. And every time a build is happening, we are running that modern code analysis, creating that code property graph, then creating a security policy from it, which is sent to the ShiftLeft SaaS console, and so that we can decorate our console using the security profile of your application in terms of where the vulnerabilities are, what important variable names are you using, etc. And it is also sent through a ShiftLeft proxy that is deployed in your private or public cloud. And from that proxy, the policy is sent to each one of our microagents that is instrumented into your applications. And as a result, the microagents don't have to talk to the ShiftLeft SaaS directly. They talk to the ShiftLeft SaaS through the proxy. And as the microagents detect issues at runtime, those alerts are sent back to the ShiftLeft SaaS dashboard, thereby allowing us to create one singular view of both the code based on its source code understanding and also the alerts from running that code into production. And it'll become real when we do the demo. So let me invite Robert to actually give you a demo of our product so that you can see it live.
Thank you very much, Manish. And hello, everyone. I am Robert Statzinger. I am a solution architect here at ShiftLeft. And I want to give you an overview of what it looks like when you're using ShiftLeft in action. As you can see on my dashboard here, I've onboarded 4 different applications into my ShiftLeft SaaS tenant. I have my employees application. I have a pet clinic application based on Spring and another Java reference application, but it's very clear where I need to be spending my time. I have a Hello ShiftLeft application here, which is showing me a red alert situation because it has both build time, code analysis violations, as well as actual runtime issues detected by the micro agent. So I really want to drill into it and understand where my security problems lie. Now, I've recently done a release of this application. So everything you're seeing here is specific to the latest release of this application that I've deployed and run with a micro agent. So you can see at the very top, I'm showing you the time at which I did a release, and ShiftLeft is instantly notifying me about a series of both build time and runtime issues. Now, the dashboard at the bottom is organized in a sort of a left to right fashion. You can see on the left the data, the trigger points that static analysis has started. You can think of these as the beginnings of logic flows or data flows moving through the application. And as we move to the right, we can see the detected violations at build time and the runtime incidents, and finally, the data destinations to which data may be leaking. Now, it's important to note here, I want to direct your attention for a moment. These are incidents or violations identified at runtime. These are not hypothetical or potential. These are actual cross-site scripting activities detected. These are actual injections detected. And these are actual leakages of sensitive data that are occurring as this application executes. On the right-hand side, I can see the actual data destination classifications. Where is this data going? Well, I can see there are an awful lot of sensitive data leaks to log file destinations or logger destinations. I can also see that there are leaks out to HTTP ports. There might be writes to files. There might be writes out to databases. So we're showing you exactly how this data might be leaking. Now, the runtime information is informing this structure by allowing me to prioritize the worst offenders. In other words, the lengths of these blue lines are telling me how bad these leaks are for given payment types. You can see the data categories at the bottom allow us to classify different levels of sensitivity and different types of data. Now, somehow, for some reason, there is payment data being sent to log destinations. Perhaps a programmer forgot to take away some debugging or triage statements, but it's quite likely that this is a very, very bad thing. So in my log destinations, I am actually writing out balances, transaction amounts, account numbers, and so forth into logged destinations. That's not a good thing and is probably something I want my developers to fix as quickly as possible. And I can help them very quickly by clicking on the detail. Now, this is what we call a flow trace in ShiftLeft. This is essentially the life cycle of that piece of sensitive data as it moves through my Hello ShiftLeft application. I can see a line number in the account class where the data is essentially born or instantiated in the scope of the application. I can see line by line level information where the data moves through different objects in different modules in the source code, and then finally as it is written out to a logger. So this is very specific, very actionable information. And you can imagine from here taking a screen cap of the data right now and sending an email to the guy on call. Very soon we'll be building into the product the ability to do things like integrate this with Jira. So imagine a ticket being filed immediately when this incident is detected and sent to the developer on call, or a notification that integrates this information into PagerDuty to get this information into your tool chains so that you can rapidly take steps to continuously improve the quality of your applications. Then the next time there's a release, you'll start to do better and better, and this dashboard will get less and less. So I'm going to make one final point here before I turn things back to Manish. The information here is prioritized. In other words, we're going to give you the most important bang for the buck. So what you can see here, for example, is the most prominent, the most high transaction prominent leaks in the application. And we do that in a couple of other perspectives as well. So for example, if I look at all of the violations currently seen in this version of the application, I can sort them by the number of actual instances. This helps me understand what I need to attack first and how I can make the biggest bang for my buck back in the development cycle to continuously improve the quality of this application. Manish?
Thank you, Robert. Let me take the ball back from Robert. There we go. Excellent. Thank you, Robert. Folks, having the ability to identify the line of code that is causing the issue at runtime is my favorite feature at ShiftLeft. We had promised you at the very beginning of this webinar that we will show you a way to protect applications without reacting to threats. A way to protect applications where we are not only protecting the application, but also improving the overall quality of the application so we see fewer and fewer incidents. So to summarize, why ShiftLeft? Agility. If you're not already in an organization which is doing one release a week or perhaps multiple releases a day, well, rest assured you will be. That is just the nature of things. And we need security tools that don't allow us, security folks, to continuously try to slow down that pace of development. Instead, we need security tools that actually leverage this pace of change to make security easier. ShiftLeft allows you to do that. Various surveys show that the future is hybrid cloud adoption. You are most likely using AWS and or Azure and some private cloud instances. You're probably using virtual machines as well as containers. Do you want to use 5 or 6 different tools to get visibility across this diverse infrastructure? Clearly not. ShiftLeft, we're giving you a way that where the infrastructure on which your application runs doesn't matter. Agnostic to encryption. When I was starting ShiftLeft, given my background in network security, one of the major problems that I continued to face every time I thought about how to solve this problem was increased use of encryption, TLS, if nothing else. And that just defeats traditional network security solutions that we are so used to. But at ShiftLeft, we see what the application sees. As a result, we do want the application to use encryption, yet we want visibility as to whether the underlying call is vulnerable or not. Application protection, not layered infrastructure. Here we are talking about the fact that yesterday when we owned our data center, we owned the physical data center. We owned the network, we owned the servers. And so protection of all of those entities was our responsibility. But now as you're taking your applications and are deploying them in AWS or Azure, really the only thing that you're responsible to protect now is your application. And well, guess what? AWS, Azure, Google Cloud, all of them talk about the same thing in what they call the shared responsibility matrix, not threat focused. Having done this for the last 15 years, if one thing I'm very clear about is that security is not going to get better if we continue to focus on threats. And at ShiftLeft, we do not worry about threats. We worry about the underlying weaknesses and the vulnerabilities in the application and protect the application against those vulnerabilities, regardless of what threats are thrown at it. And finally, as I said earlier, my favorite part of ShiftLeft, which is where we identify the line of code. If you only have to compare and contrast this with how this would work in your environment today. If you have a web application firewall, it would probably create an alert to say, I see an attack pattern. And if it meets some sort of a criteria, it'll be investigated by the SOC. And if it meets a severity level, it gets to the engineering team who will then QA it, and it'll take them weeks, perhaps days, to identify where in their software is the issue. That days to weeks can be shortened in the world of ShiftLeft in a matter of minutes. And that is why we call the company ShiftLeft. Not only do we help you protect the application in production, we also help you improve it, thereby bringing the two disparate sides of code together for the first time, the development and production. Well, thank you so much for paying attention and listening. I invite you to visit our website. There's lots of blogs, white papers that you can use if you want to dig deeper into the shift left approach. And of course, also a way to contact us if there is interest on your end to try out the shift left approach to protecting applications. Thank you once again.
Did that end it, Manish? This is actionable information.